Hi, welcome back. We are going to cover dynamic programming from basic to advanced in this series and we will master it. So before moving ahead, let's see the agenda for this lecture. First, why do we need DP at the first place? And what is the requirement of DP? And what kind of problem it really solves? Second, we will see what is DP. Next, we will see how to solve it. And this is really important. If you don't have right approach, you will stuck every time. You will develop a kind of algorithm which will solve any kind of DP problem easily. You have to repeat just this every time and you will get the answer. And lastly, we will see the problem set which we are going to cover in this playlist. So why DP? First thing is to reduce the computation cost. Computation cost means, look, you might have observed in computer science that the whole idea of CS is to make the system as fast as possible, and second is to reduce the infrastructure cost. And how can we achieve this goal? This can be achieved either through making a better hardware or developing a better algorithm or a better optimization technique. So, and people have time to time have discovered lots of algorithm and tried to achieve this goal. And one of those technique is dynamic programming, and it's very powerful. By saying powerful means that, look, if you have any problem which can be solved through recursive function, it will take most of the time exponential time, and any programming having the exponential time is not a good idea, because it will crash your system. So we want to have a better algorithm which can take less time, or a better technique. So this can be reduced to polynomial time. By saying polynomial means n square, n cube, so on. But most of the time we will deal with these three. So how do we achieve this polynomial time? Look, there are two techniques. One is greedy and second is dynamic programming. You might have heard about greedy. So look, here greedy might be faster than the DP, means it will take less time than DP, but greedy may not give the optimal answer, but dynamic programming will guarantee you the optimal. And for any problem, what do we want? We want the best answer what we can get. So dynamic programming is used to solve the optimization problem. Optimization is the best possible result for any problem. So what kind of optimization problem be? Like longest, smallest, or shortest, or maybe number of ways, find number of ways, or counting problem. This kind of problem usually deals with optimization technique, and it can be efficiently solved through dynamic programming. Next, we are going to look what is dynamic programming. So what is DP? In short, we can say, don't solve the problem twice. It means if you are solving a problem twice, I mean computer is solving the twice. If your algorithm is solving the problem twice, means it is not DP. DP means for each sub problem you solve only one time. To solve only one time, you need to identify the two characteristics of this DP problem. First is optimal substructure, and second is overlapping subproblem. Optimal substructure means for every subproblem, get the best result for that subproblem and add it to the bigger problem. And overlapping subproblem means that the problem is being get repeated again. For example, for this bigger box, if you have subproblem this and it is being repeated again, this is subproblem. So we can see by an example. Suppose we need to find the shortest distance between Delhi and Kolkata, in shortest path. How can we approach this problem? First, we need to divide this problem into in subpaths. For example, we may have sub town between Delhi and Kolkata like Lucknow and Patna. If we find the sub problem this and this, and we find the optimal answer for this sub problem, we will get the result for the entire D and K. I mean, from D to L, suppose we have the shortest path P1, and now we have, if we have to find from D to P, since we now that from D and L we have P1, we don't really need to find again from D and L, because this problem is being repeated and this is our optimal one. So why do we calculate again? Just calculate for P2, and we get for D to P as suppose okay P1 and P2. And now we have to find from D to K. We have L and P. We know from D to L as P1 and L and P as P2. Now we need to just calculate from P to K, because from D to L we have already P1, from L and P we already have P2, and these both two are optimal, and there can't be a better any path than these two. So we have optimal for till P. Just we need to from P to K. Suppose we have P3, this is the shortest one between P and K. So what we get? We got P1 from D to L, P2 from L to P, and P from P3 from P to K. And this is the shortest path for the entire path from D to K. And for each subpath we have the optimal substructure which gives the optimal result for that subpath. That is the optimal substructure. Now we will see overlapping subproblem. Overlapping subproblem. So you might have read about Fibonacci series, which is like 1 1 2 3 5 8 13 so on. So if you know its recurrence relation, it's okay. If you don't know, we are going to cover in lecture 1 and we will prove it. So its recurrence relation is something like Fi, that is the ith Fibonacci number. So for base case what we have 0 and 1 2 3 4. If we can see for base case we have 1, that is I lesser than 1 and greater than 1 we have f of I minus 1 plus f of I minus t. Sorry, f of I minus 2, since 2 here is sum of previous two terms, 3 is previous sum of previous two terms. So fi1 minus fi2. If we draw the recursion tree for it, it would be like for f of 5 4 3 3 2 2 1 f of 2 f of 1 f of 1 f of 0 f of 1 f of 0 f of 1 and f of 0. So what we are seeing here, that the problem is being repeated again and again. Here we have already calculated and we are again calculating it, so it may cost you. So we don't really need to calculate again. And here again we have f2, we need calculating again. f1 and f2 as well, we have base case denominator at all. again we are recalculating. So if we are solving again, then it doesn't make sense. So you can store the value what you have calculated so far. So we will discuss and in how to do these techniques. Look, what people do really mistake in DP problem, either they directly jump to code or they just filling the table. I mean, these things doesn't make sense. How can you just jump to these things? You need to formulate the things first for DP problem. That is, I mean, you have to find the recurrence relation, like as we did in the case of Fibonacci. Since Fibonacci is very well-known problem, you know that, and very easy, so you easily do it. But for the other problem which is not well-known and can be first time seen, you may stuck. So you should go for it. You can't do this. These are very nonsense thing. Avoid it. And what are the steps to solve problem? First is play. Play means, I mean, understand the problem, see how problem behaving, and find the sub problem, either they are repeating or not repeating, which is the characteristic of dynamic programming, and other is sub problem repetition, and second is optimal sub problem. You know, you understand these things, and once you get it, develop recurrence relation and write the recursive function like fi or fx, whatever you can say. Develop it, and once you did it, now you can code in any of these three methods, either recursive, memoization, or iterative. Recursive most of the time will be exponential, just for learning people, or maybe in interview they ask. But if you got this recurrence relation, you already get it. You don't really need to write it. If you can manage to make understand the interviewer, they will understand what is going on here. And in recursive, if you add a memory, I mean any cache, that is array or any kind of, you get the memoization. It is just one step of this recursive. And third is iterative, and you should always go for iterative. You can go for iterative if you can write recurrence relation properly, then you don't need to worry about these two things. And why you should go for iterative? Because it will beat always the memoization form, and also further on you can optimize iterative form. So you should always go for iterative form. Also, when you understand and you have got the ability to develop the recurrence relation, you will always prefer to go for iterative. I'm saying you want to go for these things. These are just for learning purpose you can do, but I don't prefer these methods. So then how to get a recurrence relation? This is the question. So to get a recurrence relation, you need to understand the problem. That's the first thing, and define the base case. What is the sub problem behaving, how it is going, and then write for general cases. And these are just practice thing. You can't develop in one day. As number of problem you will solving, eventually your idea and intuition will develop, and over the time you will able to develop it. So also one thing is that why you should go for recurrence relation. Look, if you get the recurrence relation, you already solve the 80% of the problem. Even if I say 100%, that will be also correct, but just for saying 80%, 20% is just picking the right data structure and writing code, means typing. This 20%, even I am giving 10% more, just you can 90-10. Just, and what is benefit of recurrence relation? Once you write recurrence relation properly, defining the state, you can easily solve the hard problem also. Any hard problem is hard. I am not saying that hard problem you can solve easily, but if you got it, you can solve it. There is no difference between hard or simple problem. But if you didn't get the recurrence relation, the easy problem or the medium problem, you will feel hard. That is the thing. So that's why people struggle, because people don't go for the core of this dynamic programming. Since dynamic programming actually is based on maths. It's not like the any other coding problem. In other coding problem, like for example, you have binary search, and you know that low and high, you always compare mid and this is pattern you do for every problem and you got the answer anyway. But here doesn't think work in this way. You have to develop function for every for every problem, then you will get the answer. So your energy should be put on getting this function rather than just coding or tabulation method. Those are not going to help you. So give time to it. Over the time you will develop it, and these things are not hard. You have to just look, you have to use these plus minus multi. These are simple operation and greater and smallest one and recursion, and you add this to and you get your recurrence relation. As simple as it. We are going to cover around 50 to 60 problems in this playlist. So from 1 to 8. Okay. So if you give around 2 hours each problem, it will take around 120 hours, and roughly if we say 100 to 150 hours. As a beginner, if you give consistently time to each problem, and in 150 hours you will be able to master it. You will do it, but you have to be remain consistent. Not only consistent, you have to be active. I mean, active means that you have to try by yourself, not only just watching the video. That's not going to help you. What you can do, for example, we have 01. We have, suppose you have 10 problems. You can look for first 4 to 5 problems. You can just watch video and understand what is going on. For next 4 to 5 video, before watching video, try to write the function. Once when you will put in effort, then you will get something. Otherwise you are just copying things, nothing going to help you. Okay, yes, it will help, but not the way you want. Okay, so give time, try to find the reference lesson, then watch the video. If you stuck, rewatch. This is how you are going to. So how can you treat this playlist? Look, when we were in like high school or in middle school, how we used to solve the problem on, for example, we had a chapter percentage. We used to solve 10 to 15 problem, then we move to next chapter. Okay, so here also you treat each of these variation as a individual chapter and do problems. The playlist cover like X problem, then you, after covering this variation, you do by yourself other 2 or 3 problems, or you can do later. So here we covering these topics around 7 to 12 problems for each topics, depending upon how much it is required to do. Look, 1 DDP, this is easy. We are going to like cadence algorithm, Fibonacci, house robbery. These are 01 knapsack. This is a very popular one because you will find many problems with it. So, and this is easy one. Initially you will feel hard, but over the time you will get to it. Okay, like here we have 01 knapsack, unbounded knapsack, and red cutting, and many more problems. LCS also we cover 5 to 6 problems. LIS, longest increase subsequence, here also we will cover 5, 6, 7 problem. Interval DP, this is important, this is little bit challenging, so here we will cover more problem. Next is grid DP, this is easy one, you can solve easily, there is nothing like it. Graph tree we may be covering here or may not be covering here, I am not sure till now. Maybe covering graph list. Bit mask digit DP, we will cover 5, 6 problem. And next is miscellaneous problem. If you want to solve, go for it. If you don't want to, don't go for it. But you can solve it too, because this is one popular one. But this is also like making choice 01 like thing. Okay, another good problem. If you want to solve, you can solve from here, or if you don't want to solve, you can no. So in all playlist you should put your effort in finding recurrence relation. You know, this is the core of the DP. If you don't get it, you don't get it DP. That is the thing. There is no way to solve it. Okay, since every DP has a recurrence relation. Okay, you get it, you solve the problem. That's it.